So let's discuss virtual DOM. What is it and what do you know about it? Wow, it's like a DOM, but only a virtual one.
It was at this moment that he knew. He fucked up.
Hi, I'm Vladimir and this is MTRA channel. Here we talk about programming and modern tech. In this video we will discuss virtual DOM, why is it so useful and why React and other frameworks need it. Let's get started. Well, virtual DOM is an important topic for React interviews. Try to Google React interview questions and you'll definitely find at least one question about virtual DOM in almost any list. So, why is it so relevant? This question is important because this technology is the core on which React works. It is all based on the architecture of the library. The idea of the library lies in the ability of JavaScript to be interpreted right in a browser. So any application on React doesn't require any servers to be written. So let's dive into theory how it works. There are three main ways of rendering web pages: client-side rendering, known as CSR, server-side rendering, or SSR, and static-side rendering. Well, let's discuss each one. The idea of static-side rendering is mostly simple. Server just generates a static document for each individual route and returns it when user hits a link. Such a scheme isn't supposed to have dynamic changes in response to a user, so that is why it is called static site rendering. The displayed page document is created with a build, and it does not depend on a dataset or user actions. In modern times, this type of site is the most useful for small informative banner sites used like a visit cards. SSR is a very popular type of site rendering. In this type, there is always a server which works with most logic and data. The server can be written in different languages, such as Java, Python, JavaScript, Go, and others. In this type of render, the server can work as a client, which manages documents that need to be rendered on particular routes. Such sites can respond to a user, update pages according to the dataset, and make requests to the server. This way is well known as a client-server architecture. Also, SSR sites can be monolithic, which means that the whole application can manage logic and interface levels together without separation on different tabs. The server in monolithic architecture manages everything: data flow, logic on both front-end and back-end, visual representations, and etc. Although the main idea of SSR is that a server oversees everything that happens on site. The server with a browser is in constant request exchange. Most pages displayed on site are processed and built on this server. The third type is client-side rendering. This type allows sites to be rendered right in a browser, thanks to the ability of JavaScript to be interpreted there.
In general, using this technology, an application built with HTML, CSS, and JavaScript, which is stored on a machine, is distributed via some domain. Users go to this site and browser uploads this build. Then HTML document pattern and styles loaded to the site one after another. After them, browser loads scripts and executes them. These scripts manage routes and what data should be requested from a backend, and what should be displayed for the user. In this technology, browser plays role of a client, managing all interface logic. But browser can't replicate database, and so this architecture requires server, which plays role of backend and manages data flow. This division is called client-server architecture, where two standalone applications play front-end and back-end roles, communicating with each other through API.
Basically, in CSR method, HTML document is loaded with styles and scripts, and it's all managed right in a browser. However, a site still has different roles and changes that can be made by a user, and there is not any server to manage everything. So, here's an example how it works. Look, it has navigation menu and it changes content and link clicking on it, but the navigation itself stays unchanged. Well, that is how client-side rendering works. Scripts in a browser manage all the tasks with user interface that server would do. And the more interesting thing here, that applications using CSR are called single-page applications. So everything said about client-side rendering is true for SPA. The reason why single-page application is called so lies in the base of CSR. As I said earlier, a build with a document is loaded to a browser and the rest is managed by scripts in the build. So the HTML document is that precise single page abbreviated in SPA. If you have already worked or initialized a React application, you may know the folder public and the index.html file. This file is exactly what is rendered. Firstly, when user opens your site, everything written in React project, I mean all the components and their structure, would be added to the document and removed from it according to the logic of the application. Well, it is important to know how SPA works because Virtual DOM solves the main problem of CSR, and the problem is render and re-render. So to make a site more interactive and responsive, developers write a lot of code that interacts with the real DOM and changes it accordingly. Okay, so just imagine you have a document and you have a component that updates it. So if to combine this, we have the updated site page. But what if we have a document and a lot of components that update in the page? It, it would definitely freeze the site. In more suitable words, the chain of changes can freeze a site or make user experience worse with just the longer time of response rate. Don't get me wrong, it is still possible to freeze a site with React and Virtual DOM. However, Virtual DOM is optimization for making updates into the real DOM, and so it's still updated, but in more faster and controlled way. And React even has some interfaces to participate in the update management using some hooks like use mema, use callback, or just a mema wrapper for a component.
Here's some short scheme how React Virtual DOM works. There are two versions of Virtual DOM, exact copy of real DOM and current version with last changes. React calculates differences between them and then updates real DOM and his exact copy. In theory, modern browsers are smart enough and they do not redraw the full page all the time. Although there are some conditions in which the browsers necessarily will render the wallet document, and that is why some frameworks like React have virtual DOM. Basically, virtual DOM takes control over changes instead of developers to avoid some mistakes and errors which may lead to unnecessary reloads or updates. There are some talks that this feature would be added to the browsers as a default scheme for updates, but I think it's obvious even if it happened, the JavaScript management would be still needed due to some cross-browser issues. Here are some concepts used by the different algorithm. Two elements of different types will produce different trees. Breadth first search is applied because if a node is found to be changed, it will re-render the entire subtree. Hence, depth first approach is not exactly optimal. When comparing two elements of the same type, keep the underlying node as the same and only update changes in attributes or styles. React uses optimization so that a minimal difference can be calculated in O from N efficiently using this algorithm. Well, virtual DOM is an important technique that controls updates of application that uses SPA. So it helps developers to create fast and more responsive applications. In addition, React has some methods to help developers to control re-renders of a particular component. However, Virtual DOM has some downside that programmers should know. The first one is the memory consumption. All that copies of real DOM takes a lot of memory to manage, and sometimes it can be crucial. Moreover, the hooks use memo and use callback, and the method memo takes extra memory too. In these cases, the developer shouldn't overuse these methods, and sometimes it requires to make decision between great performance and saving memory. This decision is choice between unknowingly better responsiveness and becoming a meme of consumption of memory like it was with Google Chrome, which is hungry to memory. And secondly, the native built-in JavaScript methods to work with real DOM, as query selector, for example, are forbidden in React. The problem here is that these methods work with real DOM, while React works with virtual DOM. To avoid errors with renders using React, it's better to use its methods to work with DOM, not the native ones. If you need to interact somehow with DOM while using React, try to use refs. So that was all I wanted to share in this video. I hope you found some interesting and useful here. If I missed something, please leave a comment. And if you like my videos, click like and subscribe buttons. And let's make the array less empty and code the future together.